From toy chatbots to board game upsets, from vacuuming robots to models that write and draw and argue back. And to see how that fuse kept burning through winters, hype cycles, and a few history-making wins, we have to rewind to the day that question landed on paper, and then follow the sparks to right now. But the road from a parlor game to world-changing tech isn't straight. It bends, breaks, and then, just when everyone says it's over, it explodes again. Here's how. Number 1, the spark and the bet. In 1950, Alan Turing publishes Computing Machinery and Intelligence, laying down the imitation game, what we now call the Turing test. He doesn't promise magic, he proposes a practical yardstick. If you can't reliably tell a machine from a person in conversation, the machine counts as intelligent enough. It's clear, bold, and re-aims the target from philosophy to engineering. 6 years later, a small summer workshop at Dartmouth gives the dream its name, artificial intelligence. John McCarthy and friends gather with a wild bet that every part of intelligence can be described precisely enough to simulate. That bet will pull in researchers for generations. Number 2, first steps and the first chill. The 1960s feel like liftoff. In 1961, Unimate clocks in at a General Motors plant, the first industrial robot on a factory line. It doesn't think, but it repeats dangerous, hot tasks without getting tired, and it proves machines can change real-world work. Around the same time, Eliza, a cheeky program by Joseph Weizenbaum, mirrors your words like a therapist, and people instantly start opening up to it. The program is simple, the human response is not. Then the 1970s bite. Funding dries up, promises outrun progress, and the field hits what's now called an AI winter. The message from the outside world is blunt. Come back when it works. Number 3, rules, experts, and a comeback. In the 1980s, expert systems bring AI back to the office. The most famous, R1/XCON, helps configure DEC's complex computer orders. Instead of human engineers juggling thousands of rules, the software does it, saving real money and errors. This is not sci-fi, it's operations and it works. Meanwhile, a quieter revolution lands in 1986. Rumelhart, Hinton, and Williams show how to train multi-layer neural networks using backpropagation. It's math meeting compute, and although the hardware is too small to make it shine yet, the recipe is on the table. When the world finally has the data in GPUs, this old idea will come roaring back. Number 4, televised wins and the data deluge. In 1997, IBM's Deep Blue beats world chess champion Garry Kasparov in a full match. It's part raw compute, part strategy, and completely headline-friendly. People argue about what it means, but one thing is obvious. Specialized machines can master elite human domains. 2 years later, Sony's AIBO trots into living rooms, a charming robotic pet that hints at emotional bonds with machines. The public is watching now. The 2000s shift the center of gravity to data. Cheap storage, the web, and bigger data sets fuel machine learning. In 2011, Google Brain kicks off inside Google, chasing large-scale neural nets. In 2011, IBM's Watson then wins Jeopardy, processing puns, clues, and trivia at game speed. In 2014, Alexa brings voice AI into homes with a wake word. AI stops being an abstract term and starts living in kitchens and pockets. Number 5, vision breakthroughs in the attention shift. In 2012, a deep convolutional network called AlexNet demolishes the ImageNet competition, slashing error rates and proving that deep learning plus GPUs plus big data can beat the old guard. It's the wow moment that kicks open computer vision. The architecture traces back to 1990s CNN ideas like Linnet. But this time the compute is finally ready. Reinforcement learning rides the wave too. In 2013 to 2015, DeepMind's DQN learns to play Atari directly from pixels. In 2016, AlphaGo defeats Go legend Lee Sedol, a feat long thought decades away. Strategy, intuition, and pattern reading. Suddenly, a machine does all three on a 19 by 19 board. Then the plot twist. In 2017, researchers publish Attention is All You Need. They replace recurrence with attention, birthing the transformer. Training scales better, context stretches further. This single architecture ends up powering translation, search, and, soon, nearly everything else. Number 6, when machines start writing back. In 2018, Google's BERT shows how to pre-train language understanding, read billions of words, learn context deeply, then fine-tune for tasks. In 2020, GPT-3 flips the script with 175 billion parameters and strong few-shot skills. Give it a couple examples and it generalizes. What once needed task-specific training now works with a simple prompt. November 2022 is a culture moment. ChatGPT wraps these ideas in a chat interface. Suddenly, writing drafts, answering questions, and explaining code feel like texting a helpful, fast reader. Within months, hundreds of millions try it. By 2024 to 2025, weekly users cross into the hundreds of millions and beyond, and multimodal models, text, image, audio, become normal conversation partners. The tech moves from cool demo to daily tool. Number 7, the guardrails era, ethics, safety, and real-world stakes. As AI shows up in hiring, medicine, education, and law, the stakes get real. Researchers push for transparency and bias checks. Companies ship alignment updates. Governments draft rules. Tooling appears to audit data sets, probe models, and explain decisions. The theme of the 2020s is clear. Not just can it work, but should we deploy it like this, here, now? AI shifts from lab sport to civic infrastructure. At the same time, models stop being just brains in a box. They become doers, agents that plan steps, call tools, browse, run code, and work across apps. The promise is boring and huge. Schedule, summarize, draft, verify, troubleshoot, on demand, across domains. And that sets up the question of the decade. Number 8, today's playbook, how humans stay in the loop. Right now, the winning pattern is human-AI teams. Let the model generate and let people set goals, critique, and decide. In hospitals, AI flags scans. Radiologists confirm. In classrooms, AI drafts feedback. Teachers tailor it to kids. In research, AI combs papers. Scientists test the ideas. The point isn't to replace judgment, it's to upgrade it. And yes, there are limits. Models hallucinate when data is thin, mirror biases when data is skewed, and they can be overconfident. So the modern workflow adds guardrails, citations, retrieval from trusted sources, sandboxes for code and human sign-off. We've learned the hard way that smart autocomplete